Chapter 7, Day 5. Here's a warm-up of the things that we've been working on recently. I'd like you to pause the video, try these questions, and then restart the video for the answers and explanation. So, the answer to the first question should be negative 10, x to the 7th, y to the 4th. Now what happens here is these are all just multiplied together inside this parenthesis, and then these parentheses just mean multiply. So we can kind of rearrange the order of any of these, and we can just go ahead and multiply the negative 2 and the 5 together to get the negative 10. And then when we're looking at the x's and y's, this would be like multiplying 3 x's together, and this would be multiplying 4 x's together. So we'd have a total of 7 x's being multiplied together, and remember that means we're just adding those exponents. And then the same is true, remember that when we have y, that's just y to the first, so when we add the y to the first and the third, that's where we get the y to the fourth. So hopefully that makes sense. So that is using just multiplying exponents together, or multiplying powers. But in the second example, we actually have power to a power. So when we go through and we work through this one, the first thing we have to remember is we are taking all of this inside the parenthesis and multiplying it with itself 3 times. So that means the y would be multiplied 3 times. The x to the second would be raised to the third power or multiplied 3 times. And so would the 3. So when we sort of distribute that 3 exponent, that becomes 3 to the third power. And it becomes x to the second raised to the third power, which is x to the 6th power. We're going to multiply those exponents together. And then we get y to the first raised to the third power, which would be y to the third. So that's what that simplifies to be. And then the second parenthesis right here is just, these are all just multiplied together. So we have times x times y to the fourth and times z to the second. So now we're back to the same point that we were at with number 1, and we just multiply all the pieces together. So this right here, you have no other numbers to multiply, and 3 to the third power is going to give you 3 times 3 times 3, or which is going to equal 27. Then we have x to the 6th right here, and we have multiplied with x to the first right here, and so that would give us x to the 7th power. Y to the third raised to the multiplied with y to the fourth gives us, adding the exponents, y to the 7th power. And then finally we just have z squared, and there are no other z's that are multiplying it with. So, all right, so these are, in today's lesson, we're going to work on the division property, or the quotient rule, when we simplify powers. So this is just a reminder of what we have done so far. Remember that when we have x to the m power, that means x multiplied m times. Okay, so now when we look at an example like 2 to the 4th power, what that means is we have 2 multiplied 4 times. And if we simplified and got an answer for that, that would be 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, so then we get into more complicated properties of power. And when we have x to the m times x to the n, when we're multiplying and we have the same base, so this is x and x, what we do when we're multiplying and we have the same base, we are going to add the exponents. And so that's why it becomes x to the m plus n power. So we're going to be adding these exponents when we have the same base. And when we have a power raised to a power, like in this third example right here, we have a power raised to a power right here. That's more powerful, and so what we're going to do is we are going to multiply these exponents together. So we're going to multiply our exponents. All right, so when we have x to the 6 times x to the second, okay, again, if we look at this the long way, this is 6x's. And then we're multiplying it with 2 more. And so that's why we are adding those exponents together, because we have 6 plus 2 more is x to the 8th. But what if we divide? What does that really look like? Well, what happens is if you write this out, this would actually be, again, 6x's on the top, and we'd have 2x's on the bottom. And when we are looking at this and we have a common factor on the top and the bottom, we can actually reduce. We can reduce by that common factor. And so what we're left with this in this problem is we're left with the answer is x to the 4th power over 1, or just x to the 4th. So when we divide, what we're doing is we're really subtracting those exponents. So what this becomes is it becomes x to the 6 minus 2. 6 minus 2, which is x to the 4th power. And that is our quotient of powers property. So if you have, in general, x to the m over x to the n, that's going to equal x to the m minus n. So again, if x is non-zero and m and n are integers, then you are going to subtract the exponents when you divide. So again, here's an example all worked out for you, where we are showing you that really you are just subtracting those exponents. And then once you, if it's a number, then you actually go ahead and you get an answer of 27. A lot of times with variables, you'll just have the letter. So again, this number 2 is worked out for you. So let's see if we can follow the strategy. Notice we took n to the 6 over n to the 1st. So 6 minus 1 is where we get our 5 right here from this 6 and the 1, 6 minus 1. So how would we do number 3? Well, again, it gets, sometimes students get very confused on what we're doing, but we can see that we have the same base, so we're going to have h, I think that's an h, to the a minus b power, and that's as simplified as we can get this. Okay, your turn. You try number 4. And you should have a to the 2 minus 5 power, but then we can simplify that to a to the negative 3. But we're not done, because we can't leave, if our answer is simplified, we will not have a negative exponent. So remember, that would become 1 over a to the 3rd, because a to the negative 3 means you're dividing by a 3 times. So those are your first answers. Let's go and try a few more. All right. Number 5. Give that one a try. Okay, so again, we are going to subtract these exponents right here. So that's going to give us y to the negative 4 minus 2, which is equal to y to the negative 6. But that should not be your answer, because that negative exponent needs to be simplified, and that belongs on the bottom of the fraction. You flip it to the other side of the fraction and make it positive. Number 6 is a little more complicated, so let's work through that one together. It's not that it's terribly hard, but we just have to think about that, the fact that what's happening here, again, is that each of these terms are just multiplied together, and so we have to take each one separately. Well, notice we have an a and an a, and those can be canceled out because they're common factors. Or you can think of it as a to the 1st over excuse me, a to the 1st, which would be 1 minus 1 is 0. So the a's actually cancel out in this case. So now if we look at, we don't have any b's to subtract, but our c, would be to the 3 minus 2 power, or c to the first power. Of course, we don't really need that 1 in there, but that's how that works out to be. All right, you try number 7. See if you can at least get some parts of it correct. Okay, so again, we're going to kind of take this number part separately right here, and we're going to think about that as a fraction. Okay, can you reduce that fraction? No, you really can't. So we're going to have negative 3 over 2 as part of our fraction. And then, well, actually, I'll just go ahead and write it as negative 3 over 2. And then I'm going to take a look at the x's. Okay, here's my next term, and I'm going to subtract 3 minus 2 to get x to the first power. And then I'm going to go ahead and take care of the y's. And the y's, again, you have a common base, so you have 4 minus a negative 2. So you have y to the positive 6 power, because 4 minus a negative 2, so y to the 4 minus a negative 2, it turns into adding 2, and that's where you get y to the 6. So you could certainly leave your answer just like that, okay? We could just circle it. Or you might write it like negative 3 x y to the 6 all over 2. Either of those are fine. All right. Now in question number 8, the first thing you need to do is you need to simplify the numerator. Because we are raising all of this parenthesis here to the second power, we have to apply that to each of those terms. So first go ahead and see if you can do that, and just keep the same denominator for now. So this should give you s to the 3 times 2, 6 power, and t to the 4 times 2, 8 power. Now we look for common, okay, bases. And so this is s to the first, so that would be s to the 6 minus 1, or s to the 5th power. Now we look at our t's. T to the 8th over t to the 5th. We're going to subtract those exponents, and that's going to give us t to the 3rd. And then that is our answer. So really, again, when you have common bases and you're dividing, you're going to subtract the exponents. When you have common bases or letters and you're multiplying, you're going to add the exponents together. But what about a fraction that's raised to a power? In the last example, we had just the numerator was raised to a power. But what if the whole fraction is raised to the power? Well, remember what this means when we're raising something to a power. All of that is being multiplied together twice. So if I wrote this out the long way, it would look like x to the 3rd over x to the 2nd multiplied with itself twice. That's what that would look like. Well, you know how to multiply those fractions together using our properties of fractions and powers. That would give us x times x to the 3rd times x to the 3rd, which is x to the 6, again, adding those exponents. And x to the 2nd times x to the 2nd is x to the 4th. Okay, but notice if we go back, and well, actually we need to simplify that because you can see we still have a common base right here, so we can reduce that, so to speak, or take x to the 6 over x to the 4th. We're going to subtract those 6 minus 4 to get x to the 2nd power, and that's our final answer. But there is a shortcut here, and basically what we can do is we can raise the numerator to that power and the denominator to that power. So now we have a power to a power, and that means we multiply those exponents. Power to a power, we take 2 times 2, multiply those exponents, and then again we get 6 minus 4. Because we have a common base, we subtract those exponents, and notice we get the same answer either way. So oftentimes when you're working through these problems, you might work through it in a slightly different way, and that is totally fine. But that is our last power rule right here today, is power of a fraction property. So if you have a over b raised to the n power, that will become a to the n power and b to the n power. So we raise both the numerator and denominator to that same power. So again, this would become 1/3 raised to the third power. I'm going to take 1 and raise it to the third power, and 3 and raise it to the third power. 1 to the third power is 1. 3 to the third power is 27. 3 times 3 is 9, times 3 is 27. Okay, you try the next one. Even though the numbers are big, see if you can figure out what to do. So, you would have 8 to the third power over 2 to the third power. And 8 to the third power is 8 times 8 is 64. Times 8 more is 512. 2 times 2 is 4, times 2 is 8. And then you reduce that fractions, and it turns out that 8 goes into 512 64 times. So, that's our fraction property, or power of a fraction property. Okay, your turn to try this next one with variables. So pause the video again, see if you can get the correct answers here. So what you should have for this problem is c to the 8th power over d to the 4th. Again, you're going to raise this to the 4th power, and you're going to raise d to the 1st to the 4th power, and you multiply those exponents together. These are not the same bases right here, c and d, so you cannot subtract those exponents. This would be your final answer. I'll work through the next one with you. Okay, but again, you are going to raise each of the pieces of the numerator to the 3rd power, and each of the pieces of the denominator to the 3rd power. So this would be 4 to the 3rd power, and w to the 7 times 3, 21. Remember, power to a power is more powerful, so multiply the exponents. And then the bottom, the numerator or denominator, would be y to the 2nd raised to the 3rd power, so multiply to get 6. I have no common letters right here to reduce, but I can simplify 4 to the 3rd, which is 4 times 4 is 16, times 4 more is 64. So we get 64 w to the 21st over y to the 2nd power. Oh, that should be the 6th power, sorry. Okay, so what happens when you have a negative exponent? No big deal, okay? You're going to do the exact same thing. You're just going to multiply those exponents together. So take 3 multiplied with -2. That's going to give you x to the -6. And then y to the 2nd raised to the -2, multiply those exponents. That gives you y to the -4. Oh, but we have negative exponents. We can't finish our answer with negative exponents. So remember, negative exponents flip to the opposite side of the fraction. So what this becomes then is y to the 4th over x to the 6th. So anytime you have a negative exponent, it becomes positive on the opposite side of the fraction. And we've gone through the reasons why that works. And so now we're just using the shortcut. Okay, your turn for number 6. Pause the video, see if you can come up with the final answer. Okay, your final answer for number 6 should be y to the 2nd over x to the 4th. If you did not get that answer, follow along with the explanation. So again, we're going to raise and multiply those exponents together. So that's going to give us x to the 3 times 2 or 6th power, and y to the 2 times 2 4th power. And then again, we need to do the same to the denominator. So x to the 5 times 2 is x to the 10. And y to the first to the second power is y to the second. And here's where we do have common bases, and that's why we subtracted the exponents to get x to the, we would get x to the negative 4 power. And then we would subtract, we have another common base of the y's, and so now we would subtract those exponents to get y to the 4 minus 2 is 2. But again, we have that negative exponent, so that's going to have to flip below, and that's why our x to the 4th wound up positive on the bottom. All right, so I've gone through some of these with you. Here are some more to practice and try on your own. So what I'd like you to do is, I'm going to stop here with the video, but what I would like you to do is try these next 5 problems, actually 7 problems, for practice of all of the properties together. And then you can check the notes for the worked out solutions to make sure that you got them correct. But this is the end of the video for day 5.